Exercise 9, question number 1. The car is traveling alone. So O to A to B, B to C, C to D, and then come back. So O to A, so we have to work out the average velocity for each stage. So O to A journey, average velocity is displacement O to A divided by time. So displacement O to A is 40 kilometer divided by, I noted out that everything is half an hour time frame. So this go to this distance, it took half an hour or 0.5. So we should know now 60 minutes mean 1 hour and 30 minutes mean 0.5 hours. 45 minutes mean 0.75 hours and 15 minutes mean 0.25 hours. So this is in decimal scales. 2 scale is going. So this is going to be 0.5. It means hours. So 40 divided by half mean multiply by 2, 80 kmh minus 1. So over B, B to C. Average velocity is displacement to B to C divided by time. So that time, A to B. So this is 60, this is 40, 60 minus 40, and that the time is again 0.5. 20 divided by 0.5, that is 40 kmh minus 1. Then B to C, average velocity is displacement to B to C divided by time. At the start in 0.60, end in 0.60, and then time is still half an hour. So half an hour, the car wait there. Answer is 0 kmh minus 1. Then C to D, average velocity, displacement to C to D divided by time. This is 100 and this is 60. So 100 minus 60 divided by, it took 1 hour. 40 kmh minus 1. And then D to E, average velocity equal displacement to D to C, D to E divided by time. So it is 100, now it is 0 after that. So 100 minus, this is 100, this level is 0, divided by time. It took 4 hours. Sorry, it is from here to here 1.5 hours. So 1.5 or 3 over 2, 100, 3 over 2, 200 over 3. And this value has to be negative because it's coming to the opposite direction. So usually we take this is positive and this direction is negative. So it is 100. So this is going to be minus 67.5. 7 kmh minus 1. This is part A. Part B. So average velocity for whole journey is total displacement is 0 and the time taken is 4 kmh and 0 kmh. The total displacement is 0 when it go back and come here. Part C, work out the average speed for whole journey. So average speed is the total distance divided by time taken. So from here to here 100, it means go to there 100, so it is going to be 200 divided by the total time taken 4 hours kilometer h. So this is going to be 50 kilometer per hour. So this is the average speed. Question number 2. Kyle drives from a home to a hotel. He drives for 2.5 hours and average velocity is 60 kilometer per hour. He then stops. So he's going to hotel. He start from O and then he stop at A. So and then he spent some time over there, like half an hour, and then he continued to A and B in the same place, then continue to C. And average velocity is given for first journey. Actually, average velocity O to A is 60 kilometer per hour. So we know average velocity O to A means displacement O to A divided by time taken, right? So displacement will write DOA. We don't know that. So this distance is 2.5. Now this has to be equal to 60. So DOA 2.5 60. So displacement from O to A is 60 times 2.5. So this is going to be 102 times 60, 120 and half of it, 150 kilometer. So this distance is 150 kilometer. Now he rests and then work out kind of average velocity is whole journey. Then you want to find this height. Then we can find, if we know this number, then we can divide by the time taken. So we need to work out the total displacement from home to the hotel. So this is the value we need to find. Now you can see that this is going to be 6 boxes here. So now this is so 6 squares represent 150 kilometers. Now from here to here there are 7.5 squares. So one square is 150 kilometer divided by 6.5, and 7.5 squares is 156.5 multiplied by 7.5. The answer is going to be, this is 6 squares, so this has to be 6, not 0.5. 187.5 kilometer. Now the total displacement is from here to here 187.5 kilometer. And part B, work out the average velocity of journey. Average velocity is total displacement or displacement divided by time taken. So we know now this is 187.5 kilometer, and if you look at this number you will see that this is 3.75. So 3.75 hours. So this is going to be 50 kilometer per hour. So don't assume when you look at, okay, this has the same gradient, this is look like same gradient, and because of that it has to be 60. Don't come that way around. If we assume this 60, and if you multiply by 0.75, so you'll get a different sum. Because they clearly mentioned that O to A is 60. They didn't mention anything about this one. So we have to come differently. This look like the gradient and this gradient is same, but they didn't mention that. Question number 3. Sarah left home at 10 a.m. and cycled north in a straight line. The diagram shows a displacement of the graph of a journey. So if I put O, A, B, C, D, she left from O and she go to A, and then she wait. So this is the waiting time. So the question 1, work out the Sarah's velocity between 10 to 11. So this is 10 and this is 11. 1 hour. So the question 1 is velocity O to A is going to be displacement divided by time. So displacement is 12 kilometer and time is 1 hour. So 12 km h minus 1. This is 12. And part B, on the journey, Sarah continued to pass her home 3 kilometers before returning. Estimate the time Sarah passed her home. So Sarah stay half an hour, then she is coming back again, and she continue up to 3 kilometers. So this is 12 go, 12 come back, and continue 3, and they need to know that the part B, what's the time that she passes. So she passes, it means you plus 12 and minus 12, 0. So this is the 0 line, the displacement is 0. So what is the time? This is, you can see that this is 12:45. So Sarah passes home at 12:45. Part C. Work out Sarah velocity for each of the last two stage. So this is one stage, last two stage. Start from here, go up to here. So this is the positive direction. So then the displacement is negative. So for velocity for BC journey is displacement divided by time. So displacement is, you can see that 12 and another 3 to this direction, opposite direction, minus 15, and time taken is, you can see from here to here, 1.5 hours. So this is going to be 10 kmh minus 1. Then the final stage, see, from here to here, at 3 kilometer, and this distance is 1 hour. Velocity from C to D journey, displacement divided by time. We know that this journey is 3 kilometer. Sorry, so he came back from home, this one. So, and this is 3 positive kilometer divided by 1 hour. So 3k, so this is minus 10. This is kmh minus 1. And part D, work out the average velocity for whole journey. So average velocity is total distance divided by time. So start from here, 12, 12, 24 plus 3, 27 plus come here 30. So 30 kilometer divided by 30 kmh minus 1. This side is positive and the opposite direction is negative. When she is going to O to A, so O to A journey, what is the speed velocity for this place, this point? What is the velocity for this point? What is the velocity for this point? Velocity for this point? The velocity is same because you can see the same gradient everywhere. So what is the speed? Speed is 12. What is the velocity? Velocity is 12 to this direction. What is the speed at this point? Speed is 12. Sarah went from here to here with the constant velocity. Not like this. Question number 4. A ball thrown vertically upwards. So a ball thrown upwards and then it come back. So this is the journey. Find the maximum height of the ball at the time and which it reached the height. So you can see that the graph is going to be like this. So this is the maximum height. You can see 2.5 meter. So maximum height is 2.5 meter, and the time taken to journey is this distance. So if you read the value here, so that is the time. So you can see that the time taken 0.75 seconds. So you can read that one as a 0.75 second, approximately 0.7. And part B, write down the velocity of the ball when it reaches to the highest point. So the ball goes there and the ball stop there and go up, stop and come down. So at the highest point, the velocity is 0. So velocity is 0 at the highest point. You can see everywhere, if you draw a tangent to any point, there is. But here it is, if you draw a tangent line, it is parallel to x-axis. Gradient is 0. Here you can see gradients everywhere. And part C, describe the motion of the ball 1 from upward. So you will take this is positive. Velocity, if we take this one positive, velocity is positive, and it is decreases up to 0. Starting point, there is a velocity and it's become 0 due to what? So because there is a deceleration. What is the size of deceleration? So the ball is going up, so it has the weight W. So F equal ma, so I'll write mg. F equal upward, so the mg is downward, so it is minus mg equal mass times a. So m to m cancel out, a equal minus g. So a equal minus g, a equal minus 9.8 g value. So this is the deceleration. If we consider the air resistance, this may be a bit different. For example, it's going up, and when you go up, the air resistance come down. Let's say F1. Then there are two forces now. Minus F1 minus mg equal m times a. Then a equal minus F1 minus mg divided by a. So that acceleration is should be more, because this value is getting larger. Not the acceleration, it is deceleration. And then the return journey, the velocity is, because we took the velocity this side positive, then the velocity is negative. And it increases until it hits the ground. if we disregarded the AR resistance, so mg is downward, it is coming downward. So if we equal ma, we'll put equation to downward, then mg equal ma, m to m cancel out, a equal g, that is acceleration. If there is a force, resistant force, what will happen? Then the ball is coming downward, resistance is going to be a resistance upward, let's say F1. So then F1 will put F equal ma to downwards, then mg is positive direction, F1 is negative the other way around, and m times downward acceleration, a equal mg minus f divided by m. If you want to find the hitting distance, that is v equal u plus at, when you put down velocity, hitting velocity, u start from 0, a is 9.8, and we know this journey time from here to here, or the same journey time for up. If we disregard the AR resistance, or you can measure from this times, and let's say this time is t0, so multiply by t0. And we'll try to fix a model for this one. You know, this is a quadratic equation, and it has maximum, and if this is two rows there, x equals 0 and x equal this value is going to be, let's say 1.5. It is time, t equal t, or t minus 0 times t minus 1.5, and but t square value has to be negative, so then if I put this one minus t minus 0 minus t times t minus 1.5, which is minus t square plus 1.5t, something like that. Just you can think about. So we'll take this height h. You can find the throwing speed as well. V equal u plus at upward, v equal 0, we know that starting one, u is starting one u naught, a is 9.8, and you can find the time taken, and then you can find the starting speed, and this starting speed and the hitting speed has to be same.